Alright, the section we're doing right now is section 3.6, which is a summary of curve sketching. Essentially, it is taking everything that we've learned so far in chapter 3 and using it all in one section to sketch a graph without actually graphing it. So the things we need to do, first step is to identify the domain and range. Then we need to find the x-intercepts, the asymptotes, and not necessarily the symmetry. We can probably just skip that part. We need to find the x values, so the critical points and possible points of inflection, which is what those two mean, and then use those results to determine extrema and points of inflection from there. We can do concave up, concave down as well. So the first things we need to identify are the intercepts. So we're just going to do the x-intercepts of this function. That's when we set the top equal to 0, and that occurs at x is -3 and +3. And then we need to identify asymptotes. So let's do vertical asymptotes first, which is when the bottom is equal to 0. Vertical asymptotes occur at -2 and 2, and the horizontal that's looking at the top over the bottom when we have the exponents. So y equals 2, they're only horizontal asymptote. We then need to find the derivative. Now, this is actually extremely time consuming to do the curve sketching process. So I'm going to skip the actual differentiating, and I'm going to give you the derivatives so we can save a little bit of time on the video here. The first derivative is 20x over x squared minus 4 squared. So from that we can find critical values. Critical values are at 0 and plus or minus 2 based on the first derivative. And again, I'm going to just skip the differentiating process to give you the second derivative, save a little bit of time. -20 times 3x squared plus 4 all over x squared minus 4 cubed. Which means that our possible points of inflection we do not have any. Okay, so our domain and range we don't necessarily need to do since we know what the vertical asymptotes and horizontal asymptotes are. That's really enough information. So we just have to make a table based on what we have figured out so far. So on top is where all of our intervals go. We have to test the possible points of inflection and the critical points in our intervals. So we go from -∞ to -2, -2 to 0, and 2 to infinity. Okay, so we probably don't need this over here. That's where we can sketch it when we're done. Okay, so we need to plug these points into not only the first derivative to figure out increasing, decreasing, but we need to plug them into the second derivative as well to figure out the concavity, and then we need to come to our conclusion about each on the bottom. Okay, so we're going to skip the plugging in process physically, but you will get the correct answers if you do this. F prime is going to be negative here. I'm going to go through and do f prime first on all the intervals. From -2 to 0. We actually forgot an interval. Let me fix that. We have to go from 0 to 2 and then 2 to infinity. We have to include all of those critical points. Okay, so from -2 to 0 we should be decreasing as well. 0 to 2 we are increasing, and 2 to infinity we are increasing. Okay, we put them in the second derivative. We should be negative, positive, positive, negative. So when we come to our conclusion on the bottom, if we have negative for the first derivative and negative for the second derivative, this means we are decreasing and concave down. Second one, we are decreasing, concave up. increasing concave up, and increasing concave down. Okay, so we need to identify any maxes or mins, and that's where decreasing and increasing changes, or vice versa. So extrema, we have one point where our increasing decreasing changes, and that's at 0. If we plug the 0 back into the original, we find that that is 4.5 or 9/2. And although our concavity changes at -2 and +2, we know that there's no points of inflection because 2 and -2 are both asymptotes, which we learned up here. So they couldn't possibly be points of inflection. Okay, so from here, we need to sketch our graph using everything that we've known so far. So we know that our we have zeros at -3 and 3. We know that we have asymptotes at -2 and 2, and a horizontal asymptote through +2 as well. We know we have a extrema, and because it goes from decreasing to increasing, that's a minimum at 4.5, which is, oops, I made that at 5.5, which should be right here. And then we're going to use those 3 points as kind of a starter and use the chart to go from there to figure out what our graph is going to look like. So from -infinity to -2, that first vertical asymptote, we are decreasing and concave down. Remembering what concave down looks like, and knowing that we're not going to touch our asymptotes. That's the first section of our graph. From -2 to 0, so from the vertical asymptote of -2 to our minimum, we are decreasing and concave up. And then from our minimum to 2, we are increasing and concave up. And then our last little section from 2 to infinity, we are increasing and concave down. So it's going to look really similar to the other half of this. Okay, so you need to have this chart to back you up, but at the very end, if you want to check your work by graphing it, you can certainly do that. Okay, so that's the process we're going to be following on all of these examples. We need to find the x-intercepts, and there are none of them. Again, I'm just going to skip the actual math work so that we can get to the actual curve sketching, because that's going to be the hardest part of this section. Vertical asymptotes. Curves at 2. Our horizontal asymptotes, we have none. Even if there are none, like our x-intercepts and our horizontal asymptotes, we still have to actually physically write that. Okay, for f prime, x squared minus 4x over x minus 2 squared. From there we can get our critical points. Zero and 4. Okay, we need to do the double derivative to find the possible points of inflection. We will get 8 over x minus 2 cubed. So our possible POI, there are none from this either. Okay, so from there we need to make our table. Intervals across the top. We go from -infinity to our first critical point, which is 0. Go to our first asymptote. It's often helpful to test that. 2 to 4, and then 4 to infinity. Okay, so we're testing this in our first derivative, second derivative, and then coming to our conclusion on the bottom. From negative infinity to 0 for our first derivative, we should have a positive value. 0 to 2, negative. 2 to 4, negative. And 4 to infinity, positive. Second derivative, negative, negative, positive, positive. So as you can see, even though 2 is not one of our critical points or possible points of inflection, we still tested it and still got a result that we wanted, a change in our concavity, in fact, because of that vertical asymptote. So that is something that we should be testing. So our conclusion then, from negative infinity to 0, is that we are increasing concave down. From 0 to 2, we are decreasing and concave down. Decreasing concave up, and increasing concave up. So from there, we're going to have to try to sketch this graph. This one is a tricky one. Alright, we know we have 0. There's our 0. We don't have any. Vertical asymptote at 2. Let's just get some points on here. Alright. And do we have any extrema? Well, we have our extrema. At 0, 0, or 0, I should say, we change from increasing to decreasing. So this one's going to be a max. And then at 4, we change from decreasing to increasing, which is a min. Okay, so let's plug those points in and figure out what they should be. The maximum occurs at 0, negative 2. And the minimum occurs at 4, 6. So we need to put in those points as well. So 0, negative 2, and 4. 1, 2, 3, 4. Oops, we did not go high enough. 6. Okay, now we're going to go with our increasing, decreasing to try to sketch the rest of it. From negative infinity to 0, so where that maximum is, we are increasing and concave down. Okay, and then after that maximum, we are decreasing and concave down, and we can't touch that asymptote, so something like that. From 2 to 4, so from the vertical asymptote up until the minimum, we are decreasing and concave up. And then from the minimum to infinity, we are increasing and concave up. Okay, so that might not be exactly what the graph looks like, but that is a very good rough sketch based on what that table shows us. Okay, we are going to continue the rest of this in the second part of the video. So if you need the rest of the section, make sure you watch part 2 of section 6.